Good day, everyone. I'm Sir RJ Layson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about rationalizing the denominator of the radicals. What is rationalization? Rationalization is the process of removing the radical sign in the denominator. To rationalize the denominator, we multiply the denominator by the appropriate expression such that the product will be a perfect nth root. When the denominator is a binomial term, that means we have two terms in there, we multiply it by its conjugate. So for example, if the binomial is addition sign, so we need to multiply by its conjugate operation, that is the subtraction. The conjugate of a binomial is a binomial of the same terms but different sign. Okay, later on we will have an example for that one. Let us simplify the following. We have 1 over square root of 81. So what is the square root of 81? That is 9. So we have 1 over 9. 5 over square root of 36. Simplify this one. Square root of 36 is 6. So we have 5 over 6. Square root of 25 over 49. So if you have square root of 25 and over square root of 49, so it's the same. So you will get 5 over 7. Next we have square root of 2 over square root of 2 over 100. So you can break this down, the radical sign here. You can make this one to square root of 2 over square root of 100. So since square root of 2 cannot be simplified, so you can remain that one into square root of 2. Square root of 100 is 10. So we have square root of 2 over 10. Then next we have square root of 49 over 144. So both square root of 49 and square root of 144 are perfect squares. So we have 7 over 12. Square root of 3 over 121. Since square root of 3 is not a perfect square, so you can remain that one into square root of 3. And then square root of 121 is 11. So we have square root of 3 over 11. So simplify by rationalizing the denominator. So we have here example number 1, 2 over square root of 3. No, we will use rationalization in this one. Now class, our goal here na dapat wala ng square root sa denominator niya, or yung radical sign there, we will remove that one. So how? We will use rationalization. So we just need to multiply both numerator and denominator by square root of 13. Since our goal here is to eliminate the radical sign in the denominator. So we have 2 times square root of 13, 2 over square root of 13 times square root of 13 over square root of 13 now. So you can direct multiply this one. 2 times square root of 13, we have 2 square root of 13. And square root of 13 times square root of 13, you can make that one in square root of 13 squared. So again, if you have an exponent 2 and index here is 2, diba class? Kay square root man na. So we can eliminate that one. So you will get 13 there. So we have 2 square root of 13 over 13. Now, we've achieved our goal that the denominator wala na po yung radical sign there. Next example, we have 3 over square root of z. So again, our goal here is to eliminate the radical sign there. So in the denominator. So we just need to multiply both sides by both numerator and denominator by square root of z. So we have 3 over square root of z times square root of z over square root of z. So direct multiplication, numerator times numerator, 3 times z, square root of z, we have 3 square root of z. And square root of z times square root of z, we have square root of z squared. So copy the numerator since it cannot be simplified na, 3 square root of z. In here, so we have an exponent 2 and index 2. You can eliminate the radical or the square root there and also the exponent. The remaining value in the denominator now is z. So we have 3 square root of z over z. Next, we have square root of 4a over c. So we can break this one into the radical sign. We can make this one as square root of 4a over square root of c. Now, since our denominator is a radical, so we need to simplify this one using rationalization. Multiply both numerator and denominator by square root of c. So we have square root of 4a over c, square root of c times square root of c over square root of c. So direct multiplication, we have square root of 4a times square root of c. We have square root of 4a over c, and square root of c times square root of c, we have square root of c squared. Since square root of 4 here is a perfect square, we can simplify this one. That's why we will get now 2 there, and the remaining values in the radical, so we have square root of ac over square root of c squared. We can eliminate square root and the exponent, so our final answer now is 2 square root of ac over c. Example number 4, we have square root of 13xy over z. So we can write this one into square root of 13xy over square root of z. Since our denominator is a radical, so we will use rationalization. Multiply both sides by square root of z. So we have square root of 13xy over square root of z times square root of z over square root of z. Multiply numerator times numerator, we have square root of 13xy times square root of z, we have square root of 13xyz, and square root of z times square root of z, we have square root of z squared. So we have here to simplify the denominator. Since our index is 2 and our exponent is 2, we can eliminate that one. So we have now square root of 13xyz over z. Next, we have square root of 15mp over 3n. Now, we can write this one into square root of 15mp over square root of 3n. Then, multiply both sides by square root of 3n by numerator and denominator using rationalization. So, you will get now square root of 15mp times square root of 3n. So, 15 times 3, we have 45 mpn. And the denominator, we have square root of 3n times square root of 3n, we have square root of 3n squared. So we have here square root of 45 mnp over square root of 3n squared. We can eliminate the square root and the exponent, so the remaining in the denominator is 3n. Now, since 45, we can factor this one into 9 times 5. Because 9 is a perfect square, we can simplify this one. So, square root of 9, we have 3. And then the remaining value in the radical, we have square root of 5 mnp over 3n. Example number 6, we have 5 square root of 6 over square root of 6m. Now, since our denominator is a radical value, so we will use rationalization. So how to use rationalization? Again, you just need to multiply both numerator and denominator by the value of the denominator. So we have square root of 6m, so as 5 square root of 6 over square root of 6m times square root of 6m over square root of 6m. Direct multiplication, we have 5 times square root of 6 times square root of 6m. So we have 5 square root of 36m. And your denominator now is square root of 6m squared. So we can eliminate this one, the radical, the square root and the exponent. So we have 6m now. And then since square root of 36 is a perfect square, we can simplify this one. We have 5 times square root of 36 is 6 times square root of m over 6m. 5 times 6, we have 30. So we have 30 square root of m over 6m. Now, we can reduce this one, 30 and 6. So their common is 6. So we have 5 square root of m over m. Since 30 divided 6 is 5 and 6 divided 6 is 1. Number 7, we have 4 square root of 2 over square root of 20yz. So we will use again here rationalization, class. So you multiply both numerator and denominator by square root of 20 yz. So we have 4 square root of 2 over square root of 20yz times square root of 20yz over square root of 20yz. So direct multiplication, we have 4 times square root of 2 times square root of 20yz. So we have 4 square root of 40yz. And the denominator, we will get square root of 20yz squared. So we get now 40. So since 40 we can factor 40 into 4, square root of 4 and square root of 10. Since square root of 4 is a perfect square, we can simplify this one. So square root of 4 now is 2. So we have 4 times 2 square root of 10yz over 20yz. So 4 times 2, we have 8 square root of 10yz divide 20yz. Now we can simplify or reduce this one. Their common is 2. We can reduce this one to 4. So we have 8 divide 4, we have 2. 20 divide 4, we have 5. So the final answer is 2 square root of 10yz over 5yz. Example number 8. We have 6 over 5 square root of 2x. Now here in the denominator, the radical only is the square root of 2x. So all you need to do, class, is you just to multiply both numerator and denominator by square root of 2z. Do not include 5 here because you can only multiply, you can use rationalization only using the radical value of your denominator. So we have here 6 over 5 square root of 2x times square root of 2x over square root of 2x. Direct multiplication, we have 6 times square root of 2x, we have 6 square root of 2x, and we have denominator 5 square root of 2x squared. So we have here, since we can eliminate the square root and the exponent here, so we have here 6 over square root of 2x over 5 2x. So 5 times 2, we have 10x. So we have now 6 square root of 2x over 10x. Simplify this one. So we have, we can reduce this one. So their common is 2. So we have 3 square root of 2x over 5x. Next, we have example number 9. We have 4 over cube root of 2. Now, here now, it's different na, class, because the value of here now is cube root. Now, our previous example is we've used square root, class. Now, our goal here, class, is to eliminate the radical sign there. So how to eliminate the radical? So we must have the same index and the same exponent now in our denominator so that we can eliminate the radical sign there. Now if you have 3 or more, class, na indices 3, 4, 5 and so on, so your goal there is to eliminate the symbol there, and we must have the index, the same value of index and the exponent to eliminate that one. So since our goal there is to have 3 square root of 2 raised to 3 to eliminate the cube root of 2 raised to 3, we can eliminate that one. We must multiply as cube root of 2 by cube root of 2 raised to 2. So that means we will multiply both numerator and denominator by cube root of 2 raised to 2 to eliminate the radical sign there of the denominator. So we have now 4 over cube root of 2 times cube root of 2 raised to 2 over cube root of 2 raised to 2. Now we simplify this one, direct multiplication. 4 times cube root of 2 raised to 2, we have 4 cube root of 4. And then cube root of 2 times cube root of 2 raised to 2. So we just need to add the exponent there, 2 plus 1. So we will get cube root of 2 raised to 3. So we have the same index and the same exponent now. So we can now eliminate the radical sign there. So our value here is 4 cube root of 4 because 2 raised to 2 is 4 over 2 na. Since we can reduce this one, their common is 2. So 4 divide 2 is 2. And then 2 divide 2 is 1. So we have 2 cube root of 4. Example number 10, we have fifth root of 32 over z. Now, we can write this one into fifth root of 32 over fifth root of z. Now, our denominator now is fifth root of z. The exponent is 1 lang. So, our goal there is we must have the same index and the same exponent to eliminate the radical sign. So, our goal again is fifth root z raised to 5. So, that means we need to multiply the z raised to 1 to fifth root of z raised to 4 so that we can get fifth root of z raised to 5. So that means we need to multiply both numerator and denominator by fifth root of z raised to 4. So we have fifth root of 32 over fifth root of z times fifth root of z raised to 4 over fifth root of z raised to 4. So direct multiplication, we will get fifth root of 32z raised to 4 over fifth root of z raised to 5. So we can eliminate now the index and the exponent since we have the same value of the index of exponent, that is 5. So we have fifth root of, now we can simplify also the 32 here. So we can change it one into exponential form. So we have 2 raised to 5, that is 32 also, and z raised to 4 over z na lang atong remaining value. So simplify this one. So what is fifth root of 2 fifths? We have 2. Then the remaining value here now is fifth root of z raised to 4 over z. Next example, we have here 3 over 5 plus square root of 7. Now, in our first slide class, no, we indicate there, if your term of your radical class is binomial, no, that means we have two terms. We have here the denominator 5 plus square root of 7. We need to multiply this one by its conjugate to simplify. So what is the conjugate of 3 over 5 plus square root of 7? We have 3 over 5 minus square root of 7. That means the different sign na class. So addition, we have here subtraction. So multiply both sides by 5 minus square root of 7. We have now 3 over 5 plus square root of 7 times 5 minus square root of 7 over 5 times 5 minus square root of 7. So we can multiply this one, direct multiplication. So we have distribute 3. 3 times 5, we have 15. And 3 times negative square root of 7, we have 3 negative 3 square root of 7. And since we have here binomial man with different sign lang, we can use the 5 squared and the minus square root of square root of 7 squared. So we have here 15 minus 3 square root of 7 over 5 squared minus square root of 7 squared by its theorem of binomial class. So we'll simplify this one class. Since their common here is 3, we can factor this one. So we have simplify first the denominator. We have 5 squared, 25. Square root of 7 squared, we can eliminate the radicals symbol. And then the exponent, we have 7. So since our numerator there class, so 25 minus 7, we have 18. Since our numerator class can be factor, their common is 3. So 3 times, so 5 minus square root of 7 over 18. Now we can reduce 3 and 18 class. So we have, their common is 3. So we have 5 minus square root of 7 over 6. So 18 divided 3 is 6. Last example, we have 5 over square root of a plus square root of b. So again, we need to multiply since it's binomial man class. So we need to multiply by its conjugate. So what is the conjugate of 5 over square root of a plus square root of b? We have 5 over square root of a minus square root of b. So we have now 5 over square root of a plus square root of b times square root of a minus square root of b over square root of a minus square root of b. So direct multiplication. So here we need to distribute 5 in each term. So we have 5 times square root of a times 5 times negative square root of b. And then by binomial theorem class, so since we have different operation lang, so we can use square root of a squared minus square root of b squared. So we have here 5 square root of a minus 5 square root of b over square root of a squared minus square root of b squared. So we can eliminate the radical sign here and then the exponent and here also. So we have the final answer, 5 square root of a minus 5 square root of b over a minus b. I hope that you've learned something out of this lesson, class. Thank you so much for watching, and please don't forget to like and subscribe, and if you have question, you can comment down. Thank you so much, class, and God bless everyone. Goodbye.